All right, let's go. So I hope all of you remember what we learned last class on simple linear regression, because we are going to go from there, right? So we are going to use the concepts that we learned and see what happens when we have multiple independent variables, right? So we are still going to have one dependent variable, but we are going to have multiple independent variables. And I'm going to do a quick recap on it, dependent and independent variables, just to warm you up. Like I said, next class is going to be your classwork 1, which is going to be 4 points. And the way the classwork is going to work is that I'm going to give you a question in class or maybe before class, right? If you want to take a look, maybe the night before, I'm going to put out the question. And then on that day, you need to submit on Canvas, right? So everything's going to be submitted online, right? And from each group, I need to see at least one submission. You can submit multiple, that's fine, but I need at least one to grade. And then I'm gonna possibly grade it within a day or two as soon as possible. Yes, so, and of course I will see you in person, right? Next class. You guys have gotten notice? Okay, cool. So we'll also probably do a short meet and greet just to see, just so that we know everyone in the class. And hopefully by the second week, I will know your names. Or third week, I don't promise, but we'll see. All right. So on multiple linear regression, we are going to look at 2 different kinds, right? And it's gonna get a little bit complicated at the end, but I still think I still think it's not too complicated. But so basically, we are first going to look at a case where the independent variables are numerical, right? What do I mean by numerical? I mean that it's a number, right? So independent variable. Remember when we did the Butler Company's example last time? Everything, the dependent variable, independent variable, they were all numerical. They were numbers, right? So we're going to look at that case for multiple regression. And then we are also going to look at a case where independent variables are categorical. And what do I mean by categorical? Meaning that they are not numbers, but they are a category, right? So for example, you can say the method of payment. So you can pay via cash, credit, or check, right? So these are 3 categories. So if you have data on how you're paying, it's going to be either cash or credit or check. So that's not going to be a number in your data. It's going to be words and categories in your data. So we are also going to see how to take care of that in regression. And for your classwork, you are going to do a multiple linear regression. All right. So just to summarize from last class, what we looked at regression model or simple linear regression, we basically said that we want to understand the data based on a linear model, right? And the linear model is y equals to y is the dependent variable. Dependent variable is related to independent variable with x on a linear fashion, right? With the parameters beta naught and beta 1. Then we had the data, and the data helped us get the estimation of the parameter, right? So basically, regression gave us the regression equation, where we could say that y, or the dependent variable, or the predicted dependent variable, is equals to b naught plus b1 multiplied by x, which is the independent variable, right? And just with the values of b naught and b1, now we have a complete equation. And then we can use that equation to predict the unknown values of y given an x. That's kind of the recipe. We're gonna follow the same recipe. We are just gonna see more x's. Okay. So when we look at multiple linear regression, it's very straightforward extrapolation of linear regression model, right? So you see, instead of having one x, now I have, and this is just theoretical, now we can have as many x's as possible, right? So in this case, we have q x's. So we are doing y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus up to beta q x3. So there are qx's, that means that there are q number of independent variables. And of course, there is the error term, and the error term here basically captures the error or captures the amount of uncertainty in the dependent variable that this linear regression cannot capture. So of course, you cannot capture everything perfectly with just those independent variables. There's always going to be some random or error term because it's a real situation. You don't know some things, how it's going to work. So there's always going to be this error term. And by doing the regression, you are basically trying to reduce the error as much as possible. Right? You're building a model, or you are getting the estimation of beta naught, beta 1, beta 2 such a way that epsilon is the least as possible. So if we remember, I'm just gonna do a similar thing as last class, but now we just have more independent variables, right? So if you remember dependent, independent variables, we generally have two kinds of variables in regression. And the first thing to do would be to understand what is your dependent variable and what is your independent. So a dependent variable is the variable that you are interested in, the variable that you are predicting, the variable that depends on something, right? And independent variables are the variables that are helping you to predict the dependent variable, right? Yes. So now let's look at these examples and let's see if you remember, right? So if I ask you to understand the effect of weather temperature and humidity on ice cream sales, what is your dependent variable?
Ice cream cells,
Right. And your independent variable?
weather, temperature, and humidity
Right.
on ice.
Yes. On humidity, right? On ice cream sales. Very good, right? So basically, you see that last time we just looked at the effect of weather temperature on ice cream sales, right? So we had one dependent, one independent. Now we are gonna still have one dependent, and we are always in your life, all of the regressions that you do, you're always gonna have one dependent because you can only understand one variable at a time, right? Understand the dependence of you're gonna predict one variable which is dependent on other variables. So in this case, we don't have just the water temperature, but we also have humidity. Right? So this is why it's a multiple regression because we have two independent variables, weather temperature and humidity. All right, how about the second one? Someone else? So whenever you give me the dependent, also give me the independent. Okay?
The COVID-19 infections, that would be the dependent variable, and the two independents would be social distancing and vaccinations.
So we all agree, right? So it's basically we are looking at COVID-19 infections. That's what we are interested in. That's what we are protecting, or that's what depends, right? It depends on social distancing and vaccination. So those two would be our independent variables. And then the last one, how about effect of price and availability on sales? So what's going to be your dependent and what's going to be your independent?
So sales would be dependent and price and availability would be independent.
Right, great. All right, so we remember that's great. Basically, so you see there is a parallel between simple and multiple linear regression. It's just adding one more. However, what it does though, computationally or how you do the regression, that completely changes. Why? Because scatter plots are 2D plots, right? So you can only do a scatter plot when there are two variables, one dependent, one independent. So when you have more than two variables, more than two independent variables, you cannot do a scatter plot for the whole data set, right? You can still do one of the independent, one of the dependent, one of the independent, one of the dependent, right? So we have to use other regression tools than scatter plot to do regression now. Okay? So the way we do regression is going to change because scatter plot is 2D. So we cannot possibly capture all three of them, right, in the same plot. Okay, so basically we are looking to write down this equation by doing the multiple linear regression. So we are going to, at the end of it, we want to get this equation where we have the numbers B0, B1, B2 up to BP, right? So then we have the model, or we have the equation. And then with that equation, then we will be able to predict y given the values of x. Any questions so far? Right. All right, so let's go to the data because I feel like we talked about it. Okay. So first, the data we are going to work with is called Butler with deliveries. If you want to work with me, you are welcome to open the data set. In fact, I would encourage you to work with me, at least for this one. The reason is because you're gonna do a lot of regression in this class, right? So I want you to make sure that you can do all the steps. So yeah, I mean, I can go very slow if you want to work with me, just to stop me at any point that you'd like. So the first thing first, you have to get the analysis tool back, right? So if you have gotten it, then it should show up on your under your data. So for me, I already have it, but I'm gonna show you how to get it. So if you have got it, then it should show up right here as data analysis. Under data, it should show up as data analysis, okay? So if you haven't, let's get it together. So you're gonna go to File, and then you are going to go to Options under File. So the good thing about this and good thing about working with your laptop is that once you get it one time, it's gonna stay in your laptop forever. However, if you're using a loaner computer in school, that every time you do regression, you have to get it because it doesn't save them. So you'd go to Options, and under Options, you'd go to Add-ins. Under Options, you'd go to Add-ins. And then you'd go right here, down here, you would see Manage Excel Add-ins and Go. You should click the Go. Once you click Go, you're gonna see your available add-ins, and Analysis Toolpack should be one of them. So just click on Analysis Toolpack. Okay. Later in this class, we're also gonna add in Solver. So if you want, you can also add in that at this time. But what I need for this class and until spring break, I need Analysis Tool. So once you select that and press OK, you should see data analysis under data. Any questions? Anyone struggling to get it?
Did you say I need the software add-in?
You need that for a later part of the class. So if you want to get it now, that's fine. But not from this class, yeah. I mean later part of the semester or optimization. Okay. All right. So let's first look at the data set. So like I said last time, we are still with the Butler Trucking Company, and the manager is trying to estimate the time based on, so in the past example, they were trying to estimate the time based on the miles for each assignment. Now I have added one more column to the data set, which is deliveries, right? So for example, the first row says assignment 1, the person has to drive 100 miles and make 4 deliveries in that 100 miles and takes a time of 9.3 hours. So manager thinks that deliveries could be important, how many deliveries they're making, because they're stopping that many times, right? So that will increase their total time of completing the assignment, right? So similarly, for the second assignment, the person has to travel 50 miles and make 3 deliveries, right? And takes 4.8 hours. So the manager wants to basically get a regression equation, right? Where he is able to predict time based on miles and deliveries. So the question is basically predict time with respect to or based on miles and deliveries, right? So what is going to be your dependent variable and what are going to be your independent variables in regression?
Travel time will be dependent.
Right, good. So travel time is going to be dependent variable and everything else is independent, right? Miles and deliveries are going to be independent. All right, so let's go ahead and do our regression, okay? And again, I'm gonna go very slow here and stop me anytime you're stuck. So what we're gonna do is not a scatter plot. So we're gonna go to data, and of course we're gonna use the data analysis, right? So you will select data analysis, and you can scroll down to find regression within the analysis tools. I have it here. You may have to scroll down a little bit to get regression. It's alphabetically written, so you can find R and then get regression. So once you select regression, you're gonna just get OK, and then you're going to get this pop-up box, right? Wait, do you guys have everything filled too? No, right? Okay, good. That's good. So let me delete everything so we can start. So you guys have it like this, right? Okay, cool. So we're gonna fill it up together. All right. So the first thing we need to tell Excel that in your regression, where is your y, right? So remember what is y? Y is dependent, right? So we need to tell Excel the range of y, where y is. So where is y in my data? It's right here, right? So we're gonna select the y and then select on time. And then basically you have to select the whole column of time, right? You can either drag it down to select everything. So basically you are gonna enter all the y. Or if you have, let's say right now you have 300, but maybe I give you like 1000. So what you could also do is that you could just select here, and then if you're using Windows, then you're gonna do Control, Shift, and down arrow to select everything. Okay? And I'm gonna write it out for you. And then if you're using Mac, then you're gonna do Command, Shift, and down arrow to select everything. But you can also just select manually, that works. So in your Y range should be, I'm gonna write it down. Oops, sorry. So your Y range should be D1 to D301, right? Because that's where your Y is, all of your Y. Make sense? All right, now for X, remember whenever you're doing regression, what is your X here? X is independent variable, right? So basically X is all of your miles and all of your deliveries, right? That's your X. So if you have multiple independent variables, they need to be side by side in your Excel sheet because I need to select them together. Okay. So I'm gonna go ahead and then select the top and then hit Control Shift down arrow. You could also do Command Shift down arrow if you're using Mac. Or you can just manually select everything. All right, so that's your Y, that's your X. Any questions so far? Any Y and X? So I just told Excel what is your dependent variable, what is your independent variable, all the data related to it. Now, in this case, Excel, you have to also tell Excel, did you select labels in your selection or not? So did we select labels? Yes, right? So we started from D1, which is the label type. So if you, it doesn't matter if you select or not, but you have to be consistent, right? So if you selected, you have to check the labels. If you haven't selected, then don't check the labels. I strongly suggest you to select the labels and then check labels because it's easier to read the output that way. Otherwise, you're going to be lost a little bit when you have more independent variables. Okay. And then I'm going to leave these things out for now, and we're going to talk about it maybe in next week. Yeah. The confidence level part. All right. And then in output, you can choose where you want your output to be. I'm just going to go ahead and choose an output range. And I'm just gonna make the output right here. Okay, so any empty space in your sheet, right? You can choose that, or you can also choose to make it in a new worksheet. So you'll get a new worksheet with output or a new workbook. But I think it's just easier to see it on the same page if we don't have that much data, right? If we have data, the sheet is full of data, then we can use a new worksheet. And I'm also not going to talk about the residuals and normal probability paths right now. So this is the basic regression output that we're going to get. Right? So if you have followed me so far, just go ahead and hit OK. And then you will see the regression output. Any questions so far? Or do we are able to follow? Okay. All right. So this is the output that we got, and if you're using a Mac, your coefficients might look a little bit different. Your numbers might look a little bit different than mine, but it doesn't matter really. It's all good. Okay. So for this class, we are gonna focus on a few things. We're gonna focus on the R-square. I'm just gonna highlight the things that we're gonna focus on in this class, and then also the coefficients. So we got the similar output, right? We ever tried? Got a similar output? Okay, cool. All right, so first thing first, do we remember the R-square that we got last time? Can anyone go back and tell me what was the R-square that we got last time? The regression that we did last time, it was
6.64 or 0.6641.
right, exactly. So I'm gonna call that regression 1, where we had time versus miles. And the R-square was 0.664. Okay. So then we did another regression where I added a few more data sets, and I added one more independent variable. Okay? So it was time versus miles and deliveries. And the R-square what is my R-square? My R-square is 0.817, right? you all got around that number, right? If you're using a Mac again, you're gonna get a little bit different number, but that's okay. So what do we think? Which regression is better? Which regression is better able to predict the unknown? Which model? In other words, which model is better?
The
The
second.
model we just did.
Exactly. That model is significantly better because R square is significantly higher, right? So there is a good increase in R square. Okay. So now one thing is when we did regression using scatter plot, we already have the equation. But now we don't. So we gotta write down the equation. And we're gonna do this multiple times. So it's important that we understand how we are writing the equation. Okay? So if you remember, the equations, the way the equation works is this, right? Y equals to B naught plus B1 x1. So x1 is my first independent variable plus B2 x2, where x2 is my second independent variable. Right? Now, these are actually my b's. So this is my b naught, and the coefficients basically are my b's, right? So intercept is basically your b naught, and then these are your b1 and b2. Right? So the way the equation is gonna work is, again, we're gonna start with y, right? So we're gonna start with time equals to, what's my b naught? It's going to be 0.127. Can anyone help me to finish the equation? So this is my b1 and this is my b2. This is my x1 and this is my x2.
So the 0.06 then miles.
0.067 multiplied by miles. Oops. Then
Plus 0.689 times deliveries.
okay, so this is going to be my regression equation. And you have to write this equation again and again. Okay? Whenever you do your regression, I'm going to ask you to give me the regression equations, right? And this is how you write them down. So you're going to get this, whenever you do a multiple regression, you are going to get an output like this. So you're going to use the coefficients, right, to write down your equation. So this is my new model. Right? So let's do a prediction quickly, and then I'll talk about what these numbers mean, just like we talked about the interpretation of P's in the simple linear groups. So let's see, what if predict the estimated time for an assignment which covers 150 miles and 6 deliveries. Can you give me the number?
Is it 14.311?
Okay, let's see, predicted time.
That's what I got.
Thank you. I think it's gonna be right, but I of course don't remember, so let me do that. So predicted time and miles and deliveries. Right, so predicted time is going to be plus this multiplied by miles plus this multiplied by deliveries. Okay, so I'm gonna do my miles as 150 and then deliveries as 6. Wait, Cooper, you got 6.
14.311.
Oh, okay, that's what you got. Okay, good.
Yeah, I did it rounded on a calculator and got the same thing.
Okay, yeah, so you don't have to give me this exact number. What I'm looking for is a number around it, right? So, and then also about the decimal points, I think as long as you take the first 3, you're good, okay? And you can approximate around that. So, you can say this as 0.067, that's fine. You don't need to be exact. All right, any questions so far? It's pretty simple, right? Okay, so this next thing that we're going to talk a little bit about is what does this coefficient really mean, right? So what does this number 0.067 mean? When we looked at a simple linear regression, the coefficient meant that if you increase miles by 1 unit, then on average, your time will increase by 0.0767 hours, right? So if this was a simple linear regression where we have only time and miles, then this coefficient would mean, I'm going to write it down, means, or the implication of the coefficient is that if 1 more mile needs to be covered, in an assignment, then on average, that will increase travel time by 0.067, right? However, now in multiple linear regression, you don't just you just not you you not only have the miles, you also have deliveries, right? So whenever you're writing an interpretation of the coefficient, you also have to tell me what's happening to the deliveries. So are you increasing deliveries as well when miles is increased, or are you keeping the deliveries same? So you have to add something about the deliveries because this equation takes miles and deliveries both.
So the delivery would add 0.698 more hours if you're making one more, or take that much away if you're making one less more.
Yes, that's from the delivery point of view, right? So that's exactly correct. But when you're interpreting 0.067, which is with miles, you still have to say, in this case, what's happening to delivery.
It stays the same.
Exactly, very good. So we have to say that if 1 more mile needs to be covered in an assignment, then while number of deliveries stay the same, then on average travel time will increase, you could say. Any questions on that? Do we understand? Okay. If we do, let's try to write down what does the number now 0.689 mean, right? The coefficient of deliveries. So this is the coefficient of miles. So the coefficients of delivery That is 0.689, or you could say 690, just rounding it up. It doesn't really matter again, it's okay. And then based on how I explained the interpretation of coefficient of miles, can anyone try to say the interpretation of coefficient of deliveries in the similar words?
If 1 more mile needs to be covered, and oh wait,
You're in the right direction.
if 1 more delivery needs to be covered, and miles stay the same, then you'll increase it by 0.689.
Exactly. We are grading very good. So that's it. So if 1 more delivery needs to be added while the mile stays the same, then on average travel time will increase by 0.69. Right? So basically I'm gonna copy this and then just change file. So now my question to you is, if 1 more miles needs to be covered and 1 more at the same time, 1 more delivery is added, how much will total time increase on average?
Somewhere around 0.757,
And how did you get that number?
adding the 2 coefficients,
Exactly,
the
very
delivery
good.
and the mile.
Yes. So you see, so what's happening? If you're adding both 1 mile and 1 delivery, then you are not adding just 0.06, you're also adding 0.6. Right? So you're just gonna add them up. And that's your answer, right? So do you understand the meaning of these coefficients? So what I might do is I might ask you to write on your next classwork, right? So I might ask you to write down the interpretation of one of the coefficients, right? Or I might give you some questions like, oh, if 1 more mile is to be covered, how much do you think a total time increase? Questions like that, right? So that just I'm looking for the coefficients. Any questions so far? Okay, if not, then let's take a break right now for 5 minutes. And when we come back, we're going to talk about categorical independent variables. There is also a practice problem. I think with the time, I thought about doing it in class, but I don't think we'll have time. So I'll just keep it for home, and then next class, of course, we do practices, right? So maybe I will bring it up then. So maybe I will do one practice before you actually start your assignment. Okay? So let's take a 5-minute break, and then I'm gonna be back at 10:34. We'll start again. All right, let's start. So we're going to talk about categorical independent variables. Okay, so far we did multiple regression, but we had all numerical values, right? Number of deliveries, those are numerical values like 1, 2, 3, 4. But we're going to look at a case where the independent variable need not look like numbers. It can look like some categories, right? But before we move on, I was just looking at the questions that I put in the slides. And do we know how to answer this question? Just want to make sure. We have talked about this, but not in these exact words. Do we have any guess on what this question means?
Is that the difference in the R squared? I didn't hear the whole question. I just sat back down.
No, actually, yeah, that's absolutely correct. So that's what it is. So basically, R squared tells you how much variation of the data can be explained, right, with a regression model. So we knew that regression 1 R square is 0.664. That means that 66.4% of the variability of time can be explained by the regression equation. Right? That's the regression equation corresponding to regression. Similarly, 81.7% of the variability of time can be explained by regression 2. So which means that regression 2 explains, 0.817 minus 0.664. So regression 2, adding deliveries in the data explains 15% variability, more of the variability of the data. So I might ask you questions like that. Instead of asking just what is the R squared, I might ask you how much of the variability can be explained by this regression equation. What I'm really asking is what is your R squared? Okay. All right, and you're going to see these kind of questions again and again, so you'll get used to them. All right, so like I said, this is a practice problem that I suggest you to do it on your own, but we are also gonna try to do it in class, next class, before we move on to our assignment. Okay? Just to do a quick warm-up. All right, so with that being said, let's move on to our categorical independent variables. Okay. So, like I was saying that so far the examples that we talked about, both qualitative examples and quantitative examples, they have considered quantitative independent variables, right? So when we talked about, let's say, ice cream cells and humidity and what was that? Weather temperature. Both of them are some values, some numerical values, right? And so we talked about everything that's numerical. But now we're going to talk about some categorical, right? So in many situations, we must work with categorical variables, such as, let's say, sex of the person. So how they're shopping maybe depends on their sex, which is either male or female. So in your data, you're gonna see male, female, male, female. It's not gonna be a value, right? 1, 2, 3, 4. Or like I said, method of payment. So how much you're buying maybe depends on method of payment. If you're paying cash, maybe you are spending more than if you're paying credit card, right? So again, the data you will have cash, credit, check, right? You're not gonna have 1, 2, 3, 4. So the idea of this lesson or this section is that how to use and interpret these categorical independent variables in regression. Again, we're going to work with the Butler data, but I'm going to add one more variable. So the Excel file that we're going to work with is called Butler Highway. I'm going to give you a minute to pull it up if you want to. It's not required, just if you want to. So once you pull it up, you will see that I have added one more column, right? So we do have data from 1 to 300. 300 assignments. And we have miles. These are the number of miles that each assignment covers. These are the number of deliveries that each assignment does. But now I also have added another column which says highway question mark. What it means is that does this assignment covers a highway in a busy period? Okay, so basically, if it does cover a highway in a busy period, chances are that they're gonna take more time. So in this data, no, the first one, no, means that assignment 1 covers 100 miles for deliveries and no highway during a busy period, right? And takes this much time, 9.3 hours. And then assignment 7, let's say, covers 75 miles, 3 deliveries, and it does go through a busy highway during a busy period. And then the time is 7.4 hours. Okay. So any questions about the data? All right. So as you can see, if you try to do regression just on this, right? So you can pull up your regression tool and you can say, okay, this is my y, and this, and this my x. Excel is going to give you an error because Excel cannot take categorical variable directly in their regression. Okay, so you have to process the data in a particular way. Now there are couple of different ways to do this, but we're going to talk about the simplest one and the easiest to work with. So what we're going to do is the following. We are going to create another independent variable, which is going to do the same thing that highway is doing here. So we are going to create a numerical variable associated with this categorical variable. Okay? Because Excel only can take numbers and not take words, right? So the way that we are going to code this numerical variable is the following. So it's going to be a 0, 1 variable. So the value of the variable is going to be either 0 or 1. So we're going to code it in a way that it is going to be 0 if there was no highway in busy period. It is going to be 1 if there was a highway in busy period in their assignment. Okay. Yes. Again, so we are going to create something called a dummy. Okay, we are going to say the highway dummy. So these variables are going to be called dummy. And we just need to create one dummy in this case. However, we will see cases where we need to create multiple dummies, and I'm going to tell you when. But in this case, we just need to create one dummy. That's basically the way it's going to code it, that the value of the dummy is going to be 0 if the assignment did not include travel on the congested segment of the highway during the rush hour. And it's going to be 1 if it has the highway during the rush hour. Okay. Now, how do I know that I need to create only one dummy in this case? So basically, the number of dummies depend on the number of levels in your categorical variable. What do I mean by that? So your dummy, number of dummies, equals to is always going to be number of levels minus 1. Okay. Now, what is number of levels? Number of levels is basically in your category, in your categorical independent variable, how many categories do you see? How many types of variables do you see? In this case, you see either yes or no, right? So only 2 types of variables. You don't see anything else, just yes or no, which means that your level in this case is 2. It's a 2-level categorical independent variable. Okay. So for example, so in this case, this is going to be 2 minus 1, which is equals to 1. So we just need to create one dummy. So let's think about our method of payment example, right? So we had credit. So if you, let's say you have a data where you have the method of payment independent variable, and you have credit, cash, check. So how many dummies do you need to create to explain that categorical variable?
2.
2, right? We agree because it's going to be 3 levels, 3 kinds of variables. So it's going to be 3 minus 1 equals to 2. Okay? So whenever you are using, you have categorical independent variable, you also have to decide how many dummies to create. And it's going to be similar to how we are creating one dummy, but let's go first start with 1, and then we will talk about if we had 2 dummies or 3 dummies, how to create them. All right. So basically, the way I'm going to create a dummy is I'm gonna, as I said, I may repeat myself, that I'm gonna say if it's yes, then I'm gonna code it as 1. If it's no, then I'm gonna code it as 0. You could also say the opposite. You could also do 1 if no and 0 if yes. It doesn't matter what you do, but you have to be consistent in understanding the output. Okay. So let's first do my way. What we're gonna do first is we need to create another column. Okay. So I'm going to select the D column and then right click, and if you are using Mac, it's going to be Control plus right click. So whenever I'm doing right click on Windows, on Mac you're going to do Control and right click, and then just select insert. So that will insert one new column on the left of the column that you have selected. So just select the whole column on D and then say enter. Can anyone tell me why I created the column on the left of highway and not on the right of highway?
To group it with the miles and the deliveries.
Right. So when we do regression, your independent variables need to be side by side, right? So if I did on the right, it's not going to work. I cannot select them together with miles and deliveries. Okay. All right. So I'm going to name it as highway dummy. So any guesses on how can I code my dummy? All I want to say is that if this is no, then give me 0, and if this is yes, give me 1. Any function that you have studied in your previous classes that can be used to write the code?
You could write if E2 equals open parentheses, no, close parentheses, or close parentheses, comma, 0, comma, 1, close bracket.
Exactly, very good. So you already know what I have to teach, right? Exactly. So there are multiple ways to do it, but then you could just do if this is, so you'll see Excel always wants to help you, right? So they will actually give you how to write it, right? So you're gonna say if E2 equals to, within quotation, yes, then give me 1, otherwise give me 0. Right? You could also say if E2 equals to no, comma, 0, comma, 1. That will also work, right? So all you want to say is that if it's yes, then give me 1, otherwise give me 0. So if you enter that, you should get a 0, right? Why? Because it's a no. So no means you should get a 0. Any question on the formula? So we are going to create lots of dummies in this class. Okay? In your homework, in your exam, we are gonna create dummies. So we are gonna go over this probably multiple times, but in assignment forms mostly. All right. So once you do that, just go ahead and drag it down, or you could also just hover here and wait for this plus sign and then double click, or just drag it down. Right? So if you have done everything correctly, then you should see ones for yes and zeros for no's. If you're getting all zeros or all 1, that means your formula is not correct. Any question on the dummy part or how we create it?
Why are they called dummies?
That's a good question. Because they are, I think, and I'm making it up, right? I think because it's dummying the categorical variable in some sense, right? You don't use the categorical variable anymore in your regression. It's dummying the categorical variable with numbers. But I might be wrong. But I think that's the reason. I just made it up right now.
I think it's just because they're stand-ins like crash test dummies or dummies in old movies when there was an explosion or something like that.
Yeah, maybe that's it. Yeah. I honestly, I never questioned that, but that's a great question. Okay. Any other question? All right. So now we are just gonna go ahead and do our regression, right? But in your regression, instead of using the highway, you're gonna use the highway dummy. Right? You cannot use highway because Excel is gonna give you an M. Okay. So highway dummy is doing the same thing as highway. We just need to write it. We just need to interpret it in a consistent way, right? So let's go ahead and do a regression. Let's go to data, again, same thing, data analysis. And then you're gonna pick regression. And then let's delete everything because you probably have everything saved from your last example. So let's delete everything and then we will start. All right, so what's going to be my Y range? Which column is going to be my Y range? So Y is going to be dependent variable, right? So now what we are trying to predict is that we are still trying to understand the travel time, but now we are predicting travel time based on miles, deliveries, and highways, whether they include a highway in a visit hour or not. Right? So which column is going to be my Y and which columns are going to be my X?
F will be the Y and B through D will be the X's.
Right. So if it's going to be Y, again, I suggest that you select labels because that makes reading outputs easier. What I did is you can just manually select or you can press Control, Shift, and down arrow for Windows or Command, Shift, and down arrow for Mac. All right. And then your X range is going to be B, C, and D. Again, you can manually drag it down or use Control, Shift, and down arrow or Command, Shift for down arrow. All right, did we select levels? Yes, right? So you're going to have to select levels. Otherwise, again, Excel is going to say something's wrong. All right, and then your output range, just let's put it somewhere here. And that's basically it. And then go ahead and hit OK. So we have the summary of. All right. So we're gonna again just look at we are going to look at our R square and your coefficients. First, let's look at my R square. So is this model better than the previous model? You can go ahead and check. What was R square before? So the R square before was, I think, 0.81 something, 817, and now it's 0.88. So yes, this is a better model than the previous one. So adding highways does explain more variability of time. Okay. How much more variability? It's probably around 7% more variability because our R square was 0.817. So next, let's write down our regression equation. Anyone wants to help me to write down regression equation?
Sure. It'd be times equals, is it negative 0.330 plus 0.067 times miles plus 0.673 times deliveries. And I guess plus 0.998 times highway dummy.
Thank you. So, do we all agree? All right. So now, can you help me predict something? Okay, let's predict. So predict. Like, so predict travel time for an assignment that covers 100 miles. Let's say 5 deliveries and does not include a highway segment in rush hour.
I have a question. So for the regression equation, where it says 0.673, wouldn't it be rounded up to 0.674?
I'm not picky about it, like I said, because it's 3.5, so you can round it up or down either way. So you can do 6.74, you can do 6.73. I'm not going to complain either.
Okay.
All right. So anyone gonna give me this prediction? I'm looking at time.
Is it 6.74?
What did I say? Miles, deliveries, and highway damage. So I said 100 miles, and let me first write down maybe the equation. So it's going to be this plus this multiplied by miles plus deliveries multiplied by deliveries plus highway dummy multiplied by. Okay. All right. So what should I put for miles? 100. What should I put for deliveries? 5. And what should I put for highway dummy?
0.
0.
0, right? So we understand that. So that is 0 because the way dummy works is that the value of the dummy would be either 1 or 0. And that's going to be universal. Even if when we create 10 dummies, the value of the dummies are always going to be 1 and 0. But when it's going to be 1 and when it's going to be 0, that's going to matter. Okay? So in this case, because I'm asking you to predict something when a highway segment is not included, that means that it's a no. In how we coded the dummy is, we said if it's no, then give me 0, right? So here you see, and then the time would be 9.7593. Did anyone else get that? Or did I make a mistake?
Yeah, that's what I got really close. Yeah.
Okay, cool. Yeah. As long as we are close, I don't mind. All right. Yes. So other way of coding the highway dummy, you could also say if it's no, give me 1, and if it's yes, give me 0. That's also fine. But just remember how you coded it. Because when I'm asking to predict, then you have to put in the associated number that you coded in, right? So whatever you coded in, you should remember. And when I'm asking to predict, you need to put the right number. All right. Last thing, before we leave, so let's talk about a little bit about these coefficients, right? So let's think about what does this number mean. So let's think about 0.998, the highway dummy, the coefficients of highway dummy. Can anyone take a try? Do you want to take a try of how to explain the coefficient of highway dummy, which is 0.998?
What is it, all else being the same, if you add one more mile or one more dummy, it'll increase your time by 0.998.
Not mile, right?
Sorry, increase your time
Yes.
if you add one
So-
highway dummy.
Yes. Exactly, very good. So we can say that all is being equal. If the delivery assignment contains the highway in rush hour, gonna increase travel time by 0.998 hours. So we do see that how much it can increase, right? The travel time. Highway dummy is the highest, right? So highway dummy, whether the assignment goes through the highway or not, has a very significant impact on the travel time. Right? So if you compare all the coefficients, the highway dummy is the highest coefficient. So the miles apparently matters the lowest, right? And the highway dummy has the highest coefficient in your regression equation, of course. All right. So again, I'm not very picky on the language as long as it's correct. Like you could also say all has been equal. If highway dummy becomes 1, then travel time increases by 0.998. I'm okay with that. As long as it's correct, I'm open to all kind of interpretations or how you write it. I don't really care. Okay. I think that's all I'm gonna cover today. I do talk about a little bit more complex categorical variables, but I think we're gonna talk about when we come back to categorical variables. Okay. I guess that's it. And if you have any questions, feel free to stay back a little bit. Otherwise, I'll see you in person on Tuesday, and before that, you'll get an announcement from me as to where to meet. Okay. All right. Sounds good. Bye.
Thank you.
Thank you. Bye.
Thank you, see you Monday or Tuesday.